So this time, let's consider functions that have indeterminate forms. Now let's consider the limit as x approaches 2 of x squared minus 4 over x minus 2. Now when we have functions of this form, what we usually do is we first apply the limits of rational functions and then we simplify after. So let's do that. Okay, so when we do that, what we get is 0 over 0. Now 0 over 0 is not equal to 1. It should never be equal to 1, and also it is not undefined. Undefined means we have a numerator that is not 0 and the denominator is 0. Now, things of this form is what we call an indeterminate form. Okay, so what is an indeterminate form? An indeterminate form is an expression, let's say h of x, that involves two functions, let's say f and g, whose limits cannot be determined by directly evaluating the limit of each function. So when we recall the product law, the quotient law, and the sum and difference law, all of them involves more than one function. And we can evaluate the limit by directly evaluating the limit of each function. But there are functions wherein that process is not possible. Okay, so let's look at some different indeterminate forms. So we have 0 over 0, infinity over infinity, infinity minus infinity, 0 raised to 0, 1 raised to infinity, infinity raised to 0. These are indeterminate forms. We will deal with this as we go along the lessons, but this time let's focus on the first case, the 0 over 0. So this is the case where we have a fraction and the limit of the numerator is 0, the limit of the denominator is 0. So naturally, the limit of the function is of the form 0 over 0, which again is an indeterminate form. So how will we deal with something like this? To get the limit at x approaches a, we simply simplify h of x by factoring the numerator and denominator to reduce the terms that approach 0. So let's illustrate this through an example. Okay, so let's look at the problem earlier. If we look at the numerator, we have a difference of two squares, which we can factor into x minus 2 times x plus 2. Now we can see that x minus 2 is a common factor. So we can factor them out, and this reduces the function to x plus 2. Evaluate the limits, we get a limit that's equal to 2. So therefore, the limit of x squared minus 4 over x minus 2 as x approaches 2 is not 0 over 0, but it is 2. So what did we learn? We learned that if we have an indeterminate form 0 over 0, we can reduce the terms that approach 0 by factoring them out of the numerator and denominator, and then we evaluate the limit. And that's it.